So my only thinking is that we should just take this principle and apply it everywhere, right? As much as possible, to create analytic pipelines from evidence-based components, and to standardize it. And so Jeff has his other contribution to this is he calls this the deterministic statistical machine, which is the idea that you have an algorithm or a pipeline that produces a deterministic result given a set of data and a minimal set of inputs. And so once this evidence-based pipeline is established, you don't mess with it, right? So I call this kind of transparent box analysis, right? So it's a box, so you don't mess with it. It's like Al Gore's lockbox. But it's transparent because you know exactly what's happening in there, right? So it's not a black box. You can see what's happening. But the point is you don't mess with it. So one of the goals of this is to reduce the so-called researcher degrees of freedom, where people can tinker with every single tuning parameter in the whole pipeline, which is kind of growing exponentially, and to kind of get whatever they want out of the analysis. So I think a lot of this is kind of analogous to something I deal with quite a bit is kind of a pre-specified clinical trial protocol. So when you run a clinical trial, you have to say everything you're going to do, including how you're going to analyze the data. And wouldn't it be nice if someone had just written this for you? Well, if you use a standardized kind of pipeline, someone has written it for you, and you can pre-specify exactly what you're going to do beforehand for a given situation. So the basic structure of this is just a cartoon. Of course, it will depend on what question you're actually trying to ask. But you have some data sets, some minimal input metadata, perhaps. And then there's a series of modules that it goes through, which could be quite long and maybe pre-processing. And so there's statistical methods involved in all these pieces here. And you can imagine there'd be like a benchmark set of data sets or a data set that is used to evaluate various types of statistical methods. And then at the end, you could produce some sort of report, which could perhaps be cut and pasted into a methods section, or posted in some public repository. So I just want to do a quick case study for what I mean by this. So one of the things that I do a lot is estimating acute effects of ambient air pollution exposure. So these are correlational types of studies. A lot of this stuff kind of originated from the 70s and 80s, so it's not like we started doing this yesterday. We have a long history of this kind of research. The basic question are short-term changes in pollution associated with short-term changes in population health outcomes. These things are usually conducted at the level of the community. And there's a lot of statistical research that has gone, some of it done by myself, that has gone into this type of analysis. So this is what the data typically look like. You have death counts, this is in New York City, going for a couple of years here, and then you have particulate matter levels down here at the bottom. And you can see there's not as much particulate matter data as there is mortality data because there's a lot of missing data. So, and basically you just want to say, is this top thing correlated with this bottom thing? So, the question is, can we encode everything that we found in the statistical and epidemiological research into a single package? And I think the answer is yes. Time series studies like this don't have a huge range of variation. And so they typically involve very similar types of data, maybe hospitalizations instead of mortality or whatnot, but it's often very similar. And so can we create kind of a deterministic statistical machine for this area? So the basic kind of pipeline would look it's a very simple pipeline. It's not a very complicated analysis for the most part. You want to check the data, see if there are any outliers, high leverage types of points. Pollution data is often skewed, so you want to check for that. Look for over dispersion. Do you want to fill in the missing data? The answer is absolutely no. There's been a lot of work done on that. It doesn't turn out well. The big question here is model selection. So one of the things that we have to worry about is kind of unmeasured confounding in these types of time series studies. So we don't measure a lot of the things that vary over time. So I guess this is like your batch effects. And so you have to, there are various approaches to estimating how do you adjust for these unmeasured confounders. We use semi-parametric regression methods to do this. So estimating the degrees of freedom for this has the most profound effect on any kind of association that you might estimate. So this is critical. So, but there's actually research on how to do this. There's been a couple of papers. One of them is mine. One of the various approaches to estimating this number of degrees of freedom, and you can settle on one or two approaches that are better than others. So we can just implement that. Other aspects of the model tend not to be that important. Whether you adjust for temperature and weather, and kind of doesn't really matter how you do that. There's other things that you're typically interested in: multiple lag analysis and sensitivity analysis. So you want to see, you can select a model here, but if you want to see if you move the model back and forth a little bit, does your association change dramatically, right? So those are the typical things that you want to see in this kind of analysis. And when I review, one paper a month of a time series study, these are the things that I always ask for. So,
Roger,
yeah.
Is there a 15-second response to why imputation bad in this setting?
Oh, because the data are missing systematically, so the pollution data is very difficult to collect, and so they typically only measure it once every 6 days. So there's 5 days of missing for every 6 days, one observation for every 6 days. So you can try to impute it, but you just add a lot of noise for a little bit of savings and bias. So my thinking, I feel like this is can't have one. Obviously, there's lots of areas of data analysis. Different problems have require different expertise. I can't handle everything, obviously. So the idea is that we could create a curated library of these machines, providing kind of the standardized state-of-the-art analysis pipelines. And state-of-the-art can have different meanings in different areas. Obviously, time series analysis of pollution is a very well-developed area. There's not a lot of research, statistical research going on. A lot of the questions have been settled. So we could have a kind of archive of these kinds of data analysis, an archive for data analysis. One analogy is this kind of Cochrane collaboration, which I don't know if many are familiar with, but it's basically an archive of evidence-based medicine. So you can go to the Cochrane collaboration, search for things like this is aspirin for headaches, or you can search for can you use vitamin C to treat asthma? And so here is a summary. It says we reviewed evidence. So they just basically do meta-analyses. They reviewed evidence from 9 clinical trials of vitamin C. In general, the evidence, the trials are very small. It's not possible to recommend either the use or the avoidance of vitamin C in asthma. It's okay, so we don't have to worry about vitamin C. It's not going to help us, but it's not going to hurt us. So this is the basis for a lot of evidence-based interventions, evidence-based treatments. So something like this could be done for data analysis, I think. So we could have packages that encode data analyses, pipelines, curated by experts, knowledgeable in the field. These don't have to be perfect solutions, but the idea is that they'd be pretty good solutions to kind of cover most of the bases. And then, so that's kind of all I wanted to say. I think, so I kind of did a bait and switch. I didn't really talk about reproducible research. But I do think it's important, except for the fact I don't think it really fundamentally addresses the kind of most important question of whether you can trust an analysis. And so I think so what I call this evidence-based data analysis, which I know some people don't like the phrase, but the idea is to kind of to come up with organized, standardized best practices for given scientific areas and questions. And it's not that I don't think they exist. It's really a question of kind of organizing and getting together and on it. I think this is something that could give reviewers a powerful tool without kind of dramatically increasing the burden on them, like requiring them to reproduce the analysis would. And I think that we should put more effort into kind of addressing the upstream aspects of scientific research.